Welcome to the Kontinuum lab. You've just witnessed the first ever presentation of my new instrument, the Harminator. Now, unlike other MIDI controllers that I've worked on lately, the Harminator is not just a new instrument, it's an entirely new kind of instrument. Take the clixophone, for example. It basically uses the fingerings from a saxophone, and the rest of the sensor setup is borrowed from earlier prototypes of mine. Or the virus pad, of course, it borrows heavily from other pad type instruments. But the Harminator really has no previous reference. There's no other electronic instrument which has this sort of sensor suite and functionality, and there's definitely no acoustic counterpart to this instrument. Although when you're playing it, it does look a little bit like you're holding a harmonica, which is where the name comes from, Harminator. Not quite harmonica, not quite a Terminator. It turns out that in making a completely new type of instrument, the difficult thing really isn't putting it all together or connecting all the sensors, although that's challenging too. The really hard thing is writing the code and finding out what everything does and why. Because as usual in the Kontinuum lab, I'm trying to make a real musical instrument here, not just a curious toy, but something that I won't get sick of after 2 days, something that I can practice and get better at playing. But that's not what this video is about. I'm not there yet. This video is about how I made it and how I made it work. So let's get started. So this build is a little bit different than my recent builds, and that's because most of these sensors here come pre-assembled. So I have these analog joysticks here, which are really cool. A quick word on how they work. There's a little potentiometer in here, and when you turn the joystick like this, that's activated one way or the other. And then on the other axis, you have the same kind of potentiometer, and you activate it by turning the joystick the other way. And then at the other end here, we have a little button, which is pressed when you press down on top of the joystick, with a highly satisfying little click. Next, we have some keys here. These are actually leftover keys from when I was experimenting with the clixophone. I don't like these very much, but I think they will serve this purpose just fine. Then I have this CNY70 module here. This is for the breath sensor. And then I have the rest of the material for the breath sensor. We have these items here which will allow me to make a pressure chamber. And these tubes will be the entry tube and the exit tube. There, that's what that looks like. And then this balloon here will be the membrane, and it will sit over the open end of this like that, and then be tied down with a rubber band. So that's the pressure chamber assembled. Once we put together the main body of the instrument, then we just need to put the CNY70 right in front of this, and we'll be able to measure the distance to that white membrane there. These two cables here, of course, are for connecting the potentiometers to the microcontroller. And then this piece of plastic here, I'm going to cut out a slice to use for the mouthpiece so that I don't have to suck on cardboard, because that is probably not good for your health. Anyway, so about cardboard. I have this piece of recycled cardboard here, which I've already bent into more or less the shape that I want. So we have this sort of rectangular tube shape here. So the next step is to mark where I want my sensors to sit. So the way I plan on holding this is more or less like so, which will put my thumbs up here, where I will then put the joysticks. Very nice. And then that leaves this space here for the keys. Okay. So now we have the position of the joysticks and the keys. It really does feel kind of like a game controller. But of course the difference is that I'm going to stick the mouthpiece on right here, and so the idea is that you play it like this. So let's try to make that mouthpiece. Put it in the middle here. Nice, that's going to work just great. So I'll need to make an exit hole for this tube as well. There. Okay. No, actually that's not going to work. Here. And there you go. So now we've situated our breath sensor, or at least the pressure chamber here, off to one side. And that means that I'm going to take the breakout board here and put it down at the other end. And I'll just take this opportunity right now to fold this down and glue the fold so that I can have this hold its shape by itself. Good. Now the pressure chamber is actually all done, but I want to build a structure around it to hold it in place, because we're going to put the CNY 70 right in front of it, and it's very important that they not move around, because we will be measuring the distance between them. I'm just actually going to make this second fold here as well and glue that in place, because it's going to help me with this next step. Yeah, nice. Okay, so that's the whole support structure for the pressure chamber all put together. I hope you can see how that works. It's really pretty simple. I'm just improvising like a structure to support all the important points, so that now this is fixed in place. And the cool thing about this is that I can still lift the whole breath sensor out like that. So I can change the balloon or do whatever I need to do, and then just slide it right back in there. So one thing that I forgot to do was actually to glue the actual sensor module onto this piece here before I put it in, but that should be okay. Bit of glue on there. There, and then I can just draw the cable around here and plug it in over here in the microcontroller. Once I figure out where I'm plugging it in, I'm not completely sure. So, let's see. Oh yeah, so then there's that. I just realized that I put the pressure chamber right underneath the position where I'm going to put the keys. So that's going to be a problem. And the other thing is that I'm going to hold this with my left hand on top of here, and that's where the USB cable is supposed to come out. So yeah, I guess that's what happens when you improvise everything. Microcontroller thing is not a problem. I'll just grab it, push it a little bit into the instrument, and then I can pull the USB cable out through the side. That'll be fine, as long as I have enough space inside here to bend it around. The pressure chamber is not that easy. I'm afraid I'm going to have to grab that whole thing and move it back also. Okay, I'm not going to make you sit through this whole process, so let's see. Can I? 1, 2, 3. Wow, that was easy. Maybe I should do that more often. Anyway, now I've moved the pressure chamber and the microcontroller as far back as I can, and now I should be able to, I need to move the keys back a little bit, and then I should be able to fit them all in this little space here, or above this little space, so that they don't interfere with the breath sensor. So yeah, let's just readjust that. So that's the new key position, and that leaves me plenty of space back here. I'm not sure it's the most comfortable position to play, but it should be fine for this proof of concept here. So, okay. So I'm going to grab one of each color for each side: green, red, white, blue, and yellow. Okay. Good. I just glue the keys down first of all. Yeah, okay, so as usual, that didn't turn out completely perfect, but again, I'm just doing a little prototyping here, so that should be fine for now. And now let's see these cables down here. Something like that. I'm just laying them down completely flat here. Cool, so now they're laying down flat there, and that means that I'm able to fold this box up again and they're not in the way. So excellent. Next thing, I'm going to plug everything in that I have so far, just so that I can keep track of where it is. So let's see. These keys here are going to be capacitive sensors, and there's 10 of them. So I'm going to be using almost all of the capacitive sensor pins on the Teensy. I'm going to start over here, and I'm going to decide just now on a whim that the numbering is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now all of the keys are plugged in, and I'll just need to, organize these cables here a little bit like that. So I have to plug in the CNY70. I'm going to put that on pin 25. And now I can connect the joysticks. And I also need to make sure that I have somewhere to pull these cables through on the side with the breath sensor. I'll probably just lay them down next to the other ones. Okay, let's do that. Okay, that feels pretty cool. Good, so then the cables, let's just start by plugging them in here so I can get an idea for where they end up. I can bend them down and probably pull them through like right here. Carefully make a hole there. Okay. Yeah, you can see they come out right here in front of the breath sensor. That looks pretty nice to me. And then we can pull these cables up here and out of the way. Now this other one here. So the camera's cutting out there. I'm not sure you got all of that, but now everything's plugged in. It's a bit of a mess in here, and I'm not sure I'm happy with where I put all the pins. I'm basically running out of analog pins because some of them are shared by the capacitive system, so I'm full up on pins right now. So I might make some changes to the pin distribution anyway, and I'll make sure to scribble that down and put it up on screen so you can see it. There, and then try to fold that up. Yes. Okay, that all of a sudden looks very cool and very promising. Let me just quickly close that up with a rubber band just to see if I can hold it shut for a second. Okay, that looks really crazy. I have no idea what I'm going to call this guy. Okay, so I can already see that it's going to be playable. I mean, I'm able to fully use the joysticks while pressing these keys here. The last thing I want to do before starting to test this out is that I really want to make some kind of mouthpiece. I mean, I can see how it would be an option to just play it with your mouth on this tube here, something like this. But I guess if you've seen any of my videos lately, then you'll know that I love mouthpieces. So I am going to make a little mouthpiece so that I can play it with my mouth straight on the box here. Cool, just a rectangular piece like that. So I need to make a hole in this. Where did I put my drill? This guy here. So then I just find the middle of the piece and go to town. The trick here is to go slowly, don't push down very hard because you'll just end up tearing the plastic. If you have a sharp wood drill, then you'll be able to score in this tiny circle until a perfectly round piece just falls out. And that's not exactly what happened there, but certainly good enough. So this hole is a little bit too small for the breath tube, but that's fine. I'm going to just grab a pencil and just push it through there. It will contract a little bit again later on, but that's cool. And then I will push the breath tube through like that. So you can see how the hole is a little bit more narrow than the tube, which is a good thing because that way we get a perfect hermetic seal. And then I'm ready to pull this plastic down over the tube. until it's in place. I want to be able to look inside for this. Let's see how that tube is doing. Yes. Get this into its final position and then make a little bend here where the corner is. Very nice. Okay, so now I need to just hot glue this down. Very important here to put the glue on the cardboard and let it cool off a little bit before you push the plastic down over it. Especially if, like me, you have a messed up hot glue gun that spits out the glue much too hot. Let it dry a little bit, just a little moment, and then you can push this down over it. Okay. Yeah, see, I was too quick now. You see how that got all deformed from the heat? Let's do the other side. Try to be a little more careful. Yeah. Just let it cool off a little bit. Nope, that really wasn't enough. Still too hot. Anyway, it's a good thing we're not looking for perfection here. So once that's set and you're fairly certain it's going to stay in place, you can then snip off the end of the tube. Maybe leave a little less than a centimeter sticking out. Something like that. Then we can also adjust the exit tube here a little bit. Maybe like that. So all that's missing now is the USB cable. Let's get one of those. Let's see. I'm going to draw the little USB cable through down here and then pull it out here and turn it around, and that way I can plug it in, pull it tight, and now it won't be in the way of my right hand here. Cool. Yeah, I have to say the rubber band I think doesn't really do it justice here as a system for keeping it closed. But I'm going to stick with that for now. There's going to be a lot of testing, opening it up and closing it again to check on cables and change stuff around. I'm very happy with the colorful keys and the general feel of it. So yeah, very interesting. As far as inventing a brand new instrument, I think that was probably the easy part. Now what I need to do is make sense of this interface here. I need to plug this into the computer and write a bunch of code and decide what all of these things here do so that I can use this guy to make some music. So let's go. Okay, we're back. So it's been a few days since that last bit that you just saw was filmed. So a few different things have happened during that time. First of all, of course, I finished the instrument and here it is. It's now fully functional. And I've gone through many iterations of the code to try to figure out some way of musically using this sensor setup here. I even decided to include a couple of extra sensors, namely these 4 buttons here and this capacitive sensor here on the mouthpiece. I also thought of a name for the instrument, which you already know because it's in the title of the video, but I'm really excited about it because I just thought of it. So I've decided to call it the Harminator. Not quite harmonica, but not quite Terminator. Another interesting thing that happened these last couple of days is that I decided to try a new camera angle for this setup here, and that's the one that you're looking through right now. So I got kind of sick of the other flat overhead angle, and so I decided to try this, and for now I'm liking it, but yeah, I don't know, we'll see. Anyway, so let's get on with it. Let's have a look at that code. So as usual, I've saved a few snapshots during development, and here is the first one. So this is pretty simple. Up here I just defined first the pin that I'll read the breath sensor on, and then the sensors here on the left side and where I will read those, and then on the right side. As you will see in this code, everything is referenced twice because I have a perfectly symmetric sensors set up here in the left and the right side. So that's what's reflected here. As you can see, the joystick has 3 outputs. There's a button, and then there's one axis and the other axis. And then we have the 5 keys here on the top, which are capacitive sensors. The buttons and this capacitive sensor here are not included until the very last code, which is where I decided to include those new sensors. So anyway, here in the main loop, we just basically read all those sensors and then print them to serial. So let's try to upload that. Excellent, let's open the serial monitor. Okay, so yeah, the readout here is a little bit unstable, but hopefully you can read that. First of all, we'll try the breath sensor. That's the one you can see right here. And we're getting a nice reversed readout, so it goes down to 300 and something. which is fine. That's plenty of resolution for a wind instrument. And now I guess you can appreciate why I put a little bit of harmonica into the name, because of the way that this thing is played. Next, let's check out the keys. They start right here. And so these have an order, starting with the red one. It goes like this: red, yellow, green, blue, and white. Okay, and as you can see, they all have a resolution of around 30 points or 20, 30, 40 points, which is fine. We only need a binary output from these anyway. And now we can have a look at the joystick, starting with the button, which currently says 1, which is fine. I'm using a pull-up resistor. So when I activate the button, it should go to 0, and that's what it does. Now let's check out axis 1. That's currently at 533. Axis 1, the way I've set it up is up and down. So that way, that takes it all the way down to 1, back to 530, up to 1023. Perfect. And axis 2 then goes up to 1020 and down to 3 or 4 or so. That's some very good readings and good resolution. And of course, the right side does exactly the same thing. So the keys all have acceptable resolution. The button works just fine. And the potentiometer, of course, right here, axis 1 and axis 2. Excellent readings, everything's working fine. Let's move on to the next sketch. So here is the second sketch. The only thing that really changes here is that I now map the readings from all of the sensors to some sensible values. So in the case of the buttons, that's binary, 0 for not pressed or 1 for pressed. And in the case of the joystick axes here, they are mapped between 0 and 127. So that's why I've had to introduce these minimum and maximum values, and also center values for the sensors that will be used for the pitch bend. And of course, everything is mirrored over on the right side. And just like before, we're only outputting a serial readout. I'm still not making any sort of MIDI output at all. So then here we read the breadth sensor, map that to MIDI values. Then we read the keys and map those to either 0 or 1. And then we can read the joystick axes separately here, axes 1 and 2, and map those to some sensible MIDI values. And then of course, all of the same thing over on the right-hand side. So let's try and upload that. Excellent. Let's open the serial monitor. So the readout is looking similar to before, but now as you can see, all of the sensors start with a reading of 0. First, we can have a look at the breath sensor, which is this one right here. Very nice. Perfectly responsive, quite sensitive, and mapped between 0 and 127. Now let's have a look at the left-hand keys, which is the second line here. And now, as you can see, when I activate them, they go to 1. In any combination, so that's great. Next, on the third line here, we have the joystick on the left side. Let's have a look at that first, the button. And now it's mapped the right way around, so now it's off and now it's on. And then we have the joystick here itself. First axis is up and down, and that is now mapped between 127 and 0 with 64 in the middle. This one is going to be used for pitch bend. Axis 2 is quite interesting here. It's mapped with 0 as the midpoint, and then it has one output, which is called in, as you can see right here. When I pull the joystick in, it has another output when I pull the joystick out. So I ended up not actually using this in the end, because this is also applied for pitch bend. I'll get back to that in a second. Anyway, the readings are working fine, and the same is the case over on the other keys here on the other side. As you can see, they're all working just fine, as is the button and the potentiometer and its 2 axes. So yes, that's working great. Let's move on to the next sketch. So here's the third sketch. As you can see, the whole variable section here up here hasn't changed very much, but I did include this little array here, which has some MIDI notes in it. This is basically a minor pentatonic scale, which I use to define what notes these keys output. So what really changes here is that instead of all these serial print commands here, I've now included the USB MIDI output. And so here's the breath sensor section where we read the sensor and then output to MIDI. And if the reading on the breath sensor is not 0, then we go on and read the keys as well. We also keep track of previous values on all the keys so that we can tell when something is changed, so that we know when to send a note on MIDI signal. So the key output depends on the breath sensor, which means that if I'm not blowing in the breath sensor, the keys don't do anything. On the other hand, if I'm blowing in the breath sensor, then I can play as many notes as I want on both sides. And then down here is where I read the sensors on the joysticks. Axis 2, at least in this version of the sketch, was outputting continuous controllers 110 and 111. So that's not what I ended up doing, so we'll just ignore that as well. And then down here, of course, we have everything mirrored over on the right-hand side, which is the case for all of these sketches. The biggest problem with this sketch was actually just the lack of any kind of filter on the sensor readings, because with all the noise I was getting on the individual sensors, the sketch was constantly outputting MIDI on every single loop, and that was causing glitches in the synthesizer, and that was no good. So let's not upload this one and instead go straight on to sketch number 4. So here's sketch 4. This was the first fully functional sketch for the Harminator. In fact, the only thing that's missing in this sketch is the octave functionality that I ended up doing with these buttons here. So everything else is working perfectly. A lot of it is still looking exactly the same as before, but there are a couple of important changes that I want to highlight. So if we get down to the part that has to do with the joystick, let's start with the button. So right now, this little section here reads the left button and notices when a new press has happened, and then it outputs a MIDI note on channel 16. So if you saw my video on the virus pad, then you know that I use channel 16 for looper control, and that's exactly what I'm doing here. So I'm using this button here on the joystick to control my looper. The left button here has 2 different outputs, and the way I do that is that I have this variable here, stopped, which I keep track of in every loop, and which changes state depending on the commands that I give to the looper. For example, if I'm currently not stopped, that means if stopped is equal to 0, that means I'm playing, and I press the left button, then I activate the overdub function. But if I am stopped, then instead I output 10, which the looper will read as a record command, and then you start a new loop. Of course, after doing that, we turn off the stopped variable so that the next time around we know that we're not stopped. And that's how that works. And the right button further down has a very similar setup with a different output for the looper. Then we read the keys, that's exactly the same as before. And then we get on to reading the potentiometers on the joystick. And this is where it gets really interesting. So what I wanted to try is the following. I want to use the joystick as a pitch bend device, just like before, but I want to be able to vary the amount of pitch bend. So moving up and down, I get the standard pitch bend range of plus and minus 2 semitones. But then moving side to side, I want to also pitch bend, but only by a semitone each way. So as you can see, I'm reading axis 1 here, and I'm storing the reading in this left axis 1 value. This is mapped between 0.63 on one side, 65 to 127 on the other side. Then I'm reading axis 2 in this section here, and as you can see, that's mapped differently. 33 to 64, that's just a semitone, and then 33 to 0, that's the other semitone. So that's only mapped over half of the range of this other section. That reading is stored in the left axis 2 value. Then I compare the 2 values with this little function here, and I output whichever one is higher. And another important thing here, I'm outputting this left-hand value here to channel number 2. But then as soon as we get down here and start reading the right-hand side, you can see that I'm outputting everything to channel number 3. And that's very interesting because I'm using Yoshimi as a software synthesizer, and it has the capacity to have independent pitch bend on each channel. So now things start to get really interesting because all of a sudden this pentatonic scale here, which seems maybe a little bit limiting, can be freely transposed up or down by a tone or by a semitone. So I'll be able to fill out the gaps between the notes and also basically play any interval that you can think of by pitch bending one side or the other or both by one tone or a semitone. So I hope you can appreciate how interesting that is. Rather than uploading this sketch, I'm going to jump straight into the 5th and final sketch because the only thing that actually changes there is the buttons here and how they're used for the octaves. So everything through here is exactly the same except these variables here for the octaves and these ones here. Then the main loop is exactly the same as well, except for here. Now this is where we'll read the left octave buttons. There's another corresponding section that does the same thing on the other side. So here we are simply reading these 2 buttons, and then depending on whether one of them or the other or none or both are pressed, I then set the left octave value here to a value. So this drags the current note down by an octave, up by an octave. This leaves it alone, and this sets it down by 2 octaves. The right-hand section for this is exactly the same, except that I have a positive value on here. So if I press both buttons down, I will actually go up by 2 octaves, which gives me quite a bit of range on the instrument. So this one we are going to upload and then open up the synthesizer and see if we can't make some noise. Cool, so here we are in Yoshimi. I've also opened up Super Looper and I've connected everything through jack. As you can see in Yoshimi on part number 1, nothing's going on, but on part number 2 we have an instrument reading MIDI channel 2, and on part number 3 we have an instrument reading MIDI channel 3, and that of course is exactly the 2 outputs from the Harminator. So let's try the basic functionality first. Let's just play a single note. As I mentioned, this is basically a wind instrument, so the keys by themselves do nothing. You have to blow in the mouthpiece to get a sound. That's great, that works exactly like you would expect a wind instrument to work. Let's try the other one. Of course, you can't really hear the difference, but I can play a different note. Cool, and now we can try to play both of those notes together. Excellent. Let's try and play the whole scale. As you can see, that's a pentatonic scale, which means that these 2 keys here together make a 5th. And so do these other 2 keys here. That makes that setup very interesting. So the next thing I want to try is the pitch bend. Let's see how that works. First we'll just try one note on the left side. That works great. Let's try the semitone pitch bend. That also works perfectly fine. So let's try the other side. That works great. And we can of course do this polyphonically as well, so let's try to play that 5th from before. And that works great. So, moment of truth, let's see if Yoshimi is able to do that separately on 2 different channels. I'm going to play the same note on both sides, sounds like this. And I'm going to pitch bend one of them up and the other one down. That's so crazy. Let's try that with an interval as well. Oh man, that is awesome. But of course there's other ways to use this as well. Say I wanted to play a more complete scale than just this pentatonic here. Well, I can just pitch bend one side of the instrument, which will give me the missing note. So that sounds like this. And there you have a very nice minor scale. Or you can get some perhaps more interesting results if you pitch bend one side by a semitone. Or you can get some pretty interesting chords, like say a major chord, or a minor 7th chord, which turns into a diminished chord by pitch bending this. So there's really quite a lot of possibilities there. And of course then I incorporated these buttons here at the very end of the project, and they do the control of the octave. So that's pretty simple. You still have your pinky free back here. So I use that to press one of these 2 buttons, either this one here or that one back there. So that sounds like this. That's down by an octave. That's up by an octave. And if I press both of them, down by 2 octaves. On the other side you get a similar result, but pressing both of them takes me up 2 octaves. So I get that really high part of the range, which is nice. Okay, the last thing that I need to show you is this sensor here. This is a lip sensor where I basically just mash my face up against the instrument, and that activates a filter. As you can see, I have basically MIDI learned this continuous controller that comes in on channel 2, and then I output it to part 2 and 3. And then I've put this vocal morph filter onto the filter in question. So as you can see on this knob down here, I'm able to activate that with my lower lip. And when I play a note, or let's say a chord, it sounds like this. So I'm super happy and proud with how this turned out, but as you can see, I'm also still completely lost in this instrument. The Harmonator is a brand new instrument with a brand new interface, And so I'll have to sit down and spend a few hours with it so I can get a little bit of confidence going to record a little bit of music for the beginning and the end of the video. So I'll see you after that. I totally forgot the very last thing that I need to show you, and that is the looper, which is activated with these buttons here. So as you can see, Super Looper is open, and we're supposed to be able to activate record with the left button. So let's just play something. Perfect. Should be able to stop it over here. So now we are stopped. As I mentioned before, I can start it again. Stop it again. If I press this button now that we're stopped, I'll record a new loop. And as you can see, it's gone straight to the overdub mode. So if I press this button now that we're playing, I will change the overdub state. Now overdub is off, I can play without recording. But if I turn overdub on and play something, then that is recorded and overdubbed. So yeah, that all works perfectly, looper included. And that is all the explaining I have in me today. Now I need to practice. Wow, what a ride. That was intense and exhilarating and mentally exhausting. I feel like the Harminator has some real potential as a true musical instrument. But of course only time will tell. I know I'm going to be playing this guy here quite a lot in the coming time, and probably also designing and building a non-cardboard, a little bit more permanent version of this instrument in the near future. So if you want to make sure that you don't miss any of that, then you should definitely subscribe right here in the Kontinuum Lab YouTube channel, turn on notifications, and also find me over on Instagram, also as Kontinuum Lab. And that's it for today. Take care until next time, and I'll see you in the Kontinuum.